In our study today, we are going to look at mathematics. So, and then we are going to begin with the elementary aspect of the mathematics. So, and that is the geometry. Geometry has been a fundamental topic in mathematics because most of the problems we solve in mathematics and physics actually depend on the geometry because we normally use figures and shapes to analyze problems in physics as well as in mathematics. So that is why we have to begin with the geometry. So we are going to look at it critically from the basics of it, and that is starting from the angles. So we are going to look at the angles that we have, the type of angles, and then we'll go ahead to look at the angles in straight lines, and then from there we now understand the basic angles that we do have so that we can use it to solve problems when we start applying them in shapes and figures. So that is mainly what we ought to do now. Now, when we look at the board, we can see that we have geometry and angles. So we have the first one there, which is the acute angle. So I would like us to look at it very well from that acute angle. So if we look at the acute angle, we can see that theta is used to represent an angle. And what is actually, so an angle is a portion or a point where two straight lines meet. We call that what? Angle. So when we look at the number one angle, which is the acute angle, we can see that acute angles are actually angles that are less than 90 degrees. So we can see that from the bracket. So angles that are is called the acute angle. So, and that is what we have here. So we can see 90 degrees is actually a vertical line and a horizontal line. The angle between them is called 90 degrees. So, but in this situation, in this condition, we can see that this angle here is not up to the straight line. So it is less than it. So that is why we call it what? Acute angle. So it is less than 90 degrees. So we need to understand what an acute angle is. They are angles less than 90 degrees. So, and this includes like 1 degree, 2 degree, 10 degree, 20 degree, 30 degrees, 70 degree, and so on and so forth, provided it is not up to 90 degrees. So we call all that angles 90, acute angle. Number two is called right angle, and the right angle, we can see right angle is equal to 90 degrees. So any angle or any straight line, two straight lines are made, and the angle between them is straight, vertical, and horizontal. So we call that right angle. This is vertical, this is horizontal. So they are meeting at an angle 90 degrees. So right angle is actually equal to 90 degrees. Number three is obtuse angle. Obtuse angle, we can see a horizontal line and another vertical line. So this dotted line is actually vertical and that shows 90 degrees. So, but the obtuse angle actually stretched more than the 90 degrees. So that means that an obtuse angle is more than 90 degrees, but they are not up to a straight line, which is the 180 degrees. So what we are saying here is that obtuse angles is more than 90 degrees, but less than 180. So we can see that from a vertical line and a horizontal line here, which depict what? A right angle. But the angle of the obtuse stretched more than that. And that is why it is called obtuse angle. So we can see here that theta is more than 90 degrees, but less than 180 degrees. So number four is actually um, a straight line angle on a straight line. So when we analyze this, we can see that this is a straight line, this is a perpendicular, a perpendicular a perpendicular line joining the straight line, horizontal line. So we can see that from here is right angle, from here is another right angle, because this is straight dividing the straight horizontal line. So we can see that 90 plus 90 here gives us what? 180 degrees. So that means that angle on a straight line, or straight line angle, is actually equal to 180 degrees. So, and then in number 5, we can see that the angle is actually like acute here, but we are not taking the interior part of the acute. Instead, we are taking the outside part of the acute. So the outside of it is not acute but reflex. So the angle, if we stretch the horizontal line here, it is going to be what? 180 degrees. But the angle stretched more than the 180 degrees, but it is not round like a circle. So that means that such an angle here, like this, is actually refers to as a reflex angle. So it stretched more than the straight line angle, but not up to a circle. So we call that what? A reflex angle. So that means that theta here is actually more than 180, but not up to 360. Okay, and then we have angle in a circle, or what we call angle at a point. So angle at a point, we can see the vertical line here, dotted line, and then with a straight horizontal line. So the angles actually turn round to form a circle. So at this point, so it formed a point. So that is why we call it angle at a point. It is actually equal to 360 degrees. So any angle at the upper end of the line and then the lower end of the horizontal line, actually they constitute the angle in a circle. So angle in a circle is equal to 60 degrees. Now, coming to this point, these are angles, straight line. So when we have parallel lines, and then the parallel lines, there are angles on them. So what type of angles are they? When we have two other straight lines meeting at an angle, what sort of angles are formed between them? So that is actually what we are going to look at here. So in this case, like I said, we ought to learn all these things and then get to know them. So whenever we see them in any diagram, in any shape, we'll be able to detect, we'll be able to say that this is an acute angle, this is a right angle, this is an obtuse angle, this is a straight line angle, a reflex angle, or angle in a point. These are the basic things that we need to understand. So we'll be able to solve problems in geometry by the time we start doing that. So in this case now, we can see two straight lines or two straight or parallel lines. So when we look at this, we can see here that this is a straight line cutting this parallel line. We call that a transversal. So transversal, we can see that angle here and angle here. The angle here is from the parallel line up to the transversal, from here up to the transversal. So they are facing the same side of the parallel line. So they are called corresponding angle. So if you look at this one again, we can see here and here, they are stretching at the same point. So, and they are facing the same side in of the transversal. So they are the right hand side, left hand side of the transversal. This P and theta and beta are actually the right side of the transversal. So they are actually equal. So when we have two corresponding angles, they are equal when they are found within a parallel line. So the same thing happens here. So we can see this is lower and this is the lower side of the parallel lines, and then this is it, this is it. So P and beta, Q and beta are actually corresponding angle. P and Q are corresponding angle. All corresponding angles are equal. So, and that is exactly what I want you to understand here. So in this case, so we have to be very careful to understand which is corresponding, whether they are at the top or at the lower part of the parallel lines. So we need to understand that very well. Whether we have 3 lines, 4 lines, four straight lines or parallel lines. So it doesn't actually matter so far they are found within the same side of the transversal. They are corresponding angles. Okay, here we have alternate angle. Alternate angle is actually when we find angles that are facing the opposite side of the parallel line in a transversal. So when we look at the transversal here, we can see that a transversal is cutting 2 parallel lines. So this other angle is facing the left-hand side of left side of the transversal. This one is facing the right side of the transversal. So the 2 angles are actually alternating each other, and that is why we call it alternate angle. So the same thing happened here. This is facing down, this is facing up, this is right of the transversal, this is left of a transversal. The same thing happens here. This is actually facing up, this is down of the parallel line. Now coming to the vertically opposite angle. So vertically opposite angle are just like a 2 straight line crossing each other. So opposite sides of the angles are equal. So the angles facing each other, they are equal. So this is a vertically opposite angle. This is a vertically opposite angle. P is equal to Q, and theta is equal to beta here. So these are the basic things that we need to understand fully well. We need to recognize them whenever we see them in any form of questions or in any form of shapes. So we'll be able to solve any problem that has to do with it. So in our next class, we are going to look at how we are going to be solving problems using all these things. All that we have learned, we are going to learn how to solve problems, be it in triangle, be it in straight line, and be it in any shape. We'll solve problems on that. And that is the end of the class. And thanks for listening. Thanks. And see you.